8F.2, short sharp exercise and straight into some folio work. So this here is just going to be an extension on 8F.1. So we'll get straight into the content and the skills will emerge through the question. So we have the weight of snapper has a standard deviation of 700 grams. Given 20% of the population weigh more than 3,900 grams, find the mean. Okay, so this is some problem solving for us where we don't know the mean, but we do know some other properties of this distribution, and it entails using the z-score to help us arrive at the answer. So here's what we know. Okay, this is the distribution of snapper. We don't know what its mean is. We do know the standard deviation is 700, and we do know the probability of it being larger than 3,900 is 0.2. That's the 20%. So what we're going to do is we're going to go, okay, well, what z-score would that correspond with? Okay, what is the z-score such that 20% of the data is larger than it? So we're going to do an inverse normal calculation on the z distribution. We're going, what is z, or even maybe let's put a k there. What is the value of k such that the z distribution being larger than k is 0.2? So this is an inverse normal calculation. Our tail is pointing to the right. Our area is 0.2. And for the z distribution, the standard deviation is 1 and the mean is 0. So if we plug that into our calculator, we get k, the z-score here, is 0.8416, 0.842, we'll treat it as. Okay, so remember the z distribution is useful for comparing different distributions. And so what it means is this result here, 3,900 grams, is 0.842 standard deviations above the mean, okay? It's 0.842 standard deviations above the mean. That's what the z-score tells us. A z-score is a measure of how far a result is from the mean. We've calculated the z-score such that the area is 20%, and so the z-score is going to be the same for both of these. Our z-score is 0.842. So then we're just going to put that in here. We know that a z-score of 0.842 is equal to the result that's the result that 20% is larger than, so that's the 3,900. Take away the mean, we don't know the mean, but we do know the standard deviation. Okay, so getting to here, that might be the trickiest part because then we're just solving a linear equation. So how did we get to here? We've said, what's the z-score that corresponds with 3,900? All right, we know area 0.2, our tail is to the right, and we have 20% of fish are larger than 3,900. What's that z-score? We've found that z-score doing an inverse normal calculation, and then we've put it in here, and now we're just going to solve for the mean. So I'm going to multiply both sides by 700, and I might just do this calculation all in sort of one go. All right, so rather than slowly evaluating things, I'm going to do it like this, 700 times 0.842. And then the way we would get the mean is take 3,900 from both sides. So we have minus, the mean is 700 times this number. Take 3,900. And then to get the mean as a positive number, we just divide both sides by -1, or multiply both sides by -1. Now, it doesn't matter what step you start to evaluate that, but we're just breaking down the mean to get it by itself. So we've got 700 times 0.842. So I've got 3,310.6, 3,310, so 3 significant figures. Okay, so we'll have another opportunity in a sec to go through a question like this. So let's move on to the next one, where we've got the percentage results for a physics class are and we've got the physics distribution. We have a mean of 17, a standard deviation of 10.5. For a chemistry class, we have a mean of 73, but a standard deviation of 12. We've got Lucy received an overall grade of 83% for physics and 85% for chemistry. Which subject did she do better in compared to her peers? So we're just going to calculate both z-scores here. Her z-score for physics is going to be her result, take the mean, divided by the standard deviation, and her z-score for chemistry is going to be the same, her result, take the mean, 73, divided by the standard deviation. So what's that? That's 1. That's going to be 13 on 10.5, which is above 1. 1.24. Okay, so there's the z-score for physics, the z-score for chemistry. Which one did she do better in? Well, she did better in physics compared to her peers because her result is further away from the mean. It's further above the mean. So the answer is physics. Okay. The maths teacher isn't prepared to publicly release the mean and standard deviation. However, he does tell Lucy 6% of the class scored better than her grade of 87%, and 13% of the class failed. They received less than 50%. Using this information, calculate the mean and standard deviation of percentage results for the maths class test. Okay, so it helps draw the diagram, draw the distribution. So here's what we have. We have 6% scored better than her. So her result is 87%. All right, and we have 6% of the class scored better than that. So that means the area above 87 is 0.06. And we also have 13% of the class failed. Okay, received less than 50%. So if this is 50%, we have this is going to be an area of 0.13 for 13% of the class. Okay, so now what we don't know what the mean is and we don't know what the standard deviation is for the maths test. So that's what we're trying to find out. So we're going to draw the z distribution and we're going to say what is the z-score here and what is the z-score here. We want to know the z-score on the z distribution. Let's call them z1 and z2. We want to know these z-scores such that this area is 0.06 and this area is 0.13 on the z distribution. We know the z distribution has a mean of 0 and a standard deviation of 1. So both of these are inverse normal calculations. All right, so here, inverse normal, tail is right, area is 0.06, our standard deviation is 1 and our mean is 0, and that's going to give us the z1 value. Right, 0.06, 1 and 0, and we've got 1.554. 1.55. Okay, and then for Z2, the tail is to the left. The area is 0.13. Standard deviation and mean remain the same. And we've got minus 1.12. 6 minus 1.13. Okay, so this result, 87%, that's 1.5 standard deviations above the mean. This result, 50%, that's 1.13 standard deviations below the mean, below because it's negative. Okay, so let's put both of those into the z-score. So we've got her result, 87%. Take away the mean. We don't know what the mean is. divided by the standard deviation. We don't know what the standard deviation is, but we know that the z-score of her result, take the mean divided by the standard deviation, is 1.55. That her result is 1.55 standard deviations above the mean. And we also know that, I need a little bit more space, might just do it down here. We also know that 50%, okay, corresponds with the z-score here. 50%, take the mean divided by the standard deviation. Okay, 50%, the result of 50% is 1.13 standard deviations below the mean. So what we have here is two simultaneous equations, and we're now going to solve for both of these unknowns, the mean and the standard deviation. So the first thing we're going to do is manipulate both of them so that they're in a form, and then we'll just chuck them in our calculator. So what I'm going to do is multiply both sides by sigma. So that would give me 87 take mu equals 1.55 sigma. And then I'm just going to plus the mean to both sides. All right, so we'll have 87 equals 1.55 sigma plus the mean. And when we type it into our calculator, we'll type it in like this. We'll have 1.55 sigma plus the mean equals 87. That's the way to type into our calculator, just reversing the equality statement. We'll do the same to this equation. Multiply both sides by sigma. Now that's a negative. Add the mean to both sides. And then when we put it in our calculator, we'll reverse it. Okay, so we've got both equations ready to go into our calculator. We can also solve these manually using substitution, using elimination. We've done simultaneous equations before. We've seen them pop up in calculus and all different types of stuff. Let's just go straight to our calculator. So menu, equation. This is a simultaneous equation, and there are two unknowns. All right, the unknowns are standard deviation and the mean. And so when we type it into our calculator, we're presented with a matrix, and we've got A, B, C, 1, 2, A, B, C, 1, 2, and we're just typing the coefficients of each equation. So 1.55 in the first cell, 1, because we've got one lot of mu. All right, the coefficient of mu is 1, and then we've got 87. Over here we've got minus 1.13 lot of sigma. We've got one lot of mu, and then we've got 50. Now, when you type this in, you must have it such that both the sigmas are in that position and both the means are in that position. They must line up with one another, okay? So, what have we got? 1.55, 187, minus 1.13, 150. And so we've got a standard deviation, okay? It's told me the first variable, okay? The first one that we input is the standard deviation, 13.8. And the mean is 65.6. Okay, so the maths test had a mean result of 65.6% and a standard deviation of 13.8%. Okay, so they'll start easy, just with one unknown, and then some of the later questions will get you to solve these simultaneous equations where there's two unknowns, but we're bringing in those z-scores to help us out. Any questions? Excellent, let's rip in.